carburetor. The carburetor was the standard fuel system for most cars through much of the 20th century. It works by using air pressure and vacuum to pull fuel into the intake stream, mixing gasoline with air before it enters the engine. The design is entirely mechanical, with no electronics involved, which made it simple to repair and tune by hand. Older American muscle cars, classic motorcycles, and many vintage European vehicles relied on carburetors because they were inexpensive and effective for their time. Their biggest limitation was precision, especially when emission standards became stricter. Single-point fuel injection. Also called throttle body injection, this system appeared as a transition between carburetors and modern fuel injection. Instead of mixing fuel through mechanical vacuum, a single electronically controlled injector sprays fuel into the throttle body, where it mixes with incoming air. It still feeds all cylinders from one central location, much like a carburetor, but with better control thanks to sensors and an engine computer. Many cars from the late 1980s and early 1990s used this setup because it improved fuel economy without requiring a complete redesign of the engine. Multi-point fuel injection. This system changed how engines delivered fuel by giving each cylinder its own injector. Those injectors are mounted near the intake ports, allowing fuel to be sprayed much closer to where combustion actually happens. That means the engine can meter fuel more accurately, improving efficiency, smoother idle, and throttle response. By the 1990s, multi-point injection became the new standard across most passenger cars because it balanced performance, reliability, and emissions control very well. Sequential fuel injection. Sequential injection is a more advanced form of multi-point injection, where each injector fires in sync with the exact timing of its cylinder's intake stroke. Instead of all injectors spraying at once, the engine control unit coordinates them individually based on crankshaft and camshaft position. This makes the fuel delivery much more precise, especially during cold starts and acceleration. It became common in modern engines because it helps squeeze more power and cleaner emissions from the same displacement. Batch fire injection. This system also uses multiple injectors, but they do not fire individually in sequence. Instead, groups of injectors spray fuel together at the same time, even if some cylinders are not yet ready to use that fuel. It is simpler and cheaper than sequential injection, which is why many earlier fuel-injected vehicles used it. While not as precise, it still offered a major step up from carburetors and was reliable enough for millions of everyday cars. Direct injection. Direct injection sprays fuel straight into the combustion chamber rather than into the intake port. That changes everything about how combustion can be controlled because the fuel arrives exactly where the spark and compression will ignite it. The result is stronger power, better fuel economy, and the ability to run higher compression ratios. This technology was once limited to diesel engines and expensive performance cars, but it is now common in modern gasoline vehicles, from compact sedans to high-end sports cars. Gasoline direct injection turbo system. When direct injection is paired with turbocharging, the engine becomes much more powerful for its size. Fuel is injected directly into the cylinders, while a turbocharger forces extra air into the engine, allowing small engines to produce power that older, larger engines needed much more displacement to achieve. This combination is now popular because automakers can meet fuel economy rules while still giving drivers strong acceleration. Many modern four-cylinder turbo cars rely on this exact setup. Dual injection system. Some manufacturers combine both port injection and direct injection in the same engine. That means the engine can choose which system to use depending on speed, load, and temperature. At low loads, port injection may be used for cleaner operation and reduced carbon buildup, while direct injection takes over when maximum performance is needed. This design is more expensive and complex, but it solves some of the weaknesses that direct injection alone introduced. Mechanical diesel injection. Older diesel engines often used fully mechanical injection pumps to send fuel at high pressure into the cylinders. The timing and quantity were controlled by gears, springs, and pump internals rather than software. This made these engines extremely durable, especially in trucks, tractors, and industrial machines. The sound of older diesel engines, with their distinctive clatter, largely came from this rugged mechanical injection process. Common rail diesel injection. Modern diesel engines use a common rail system where fuel is stored in a shared high-pressure rail and delivered to electronically controlled injectors. This allows very precise injection timing and multiple injections during a single combustion cycle. Compared to older mechanical systems, it makes diesel engines quieter, more efficient, and much cleaner. Nearly every modern diesel passenger car, pickup truck, and heavy-duty commercial vehicle now uses some form of common rail technology. Unit injector system. In this setup, each cylinder has its own integrated injector and high-pressure pump combined into a single unit. Instead of relying on one central pump, pressure is created individually at each cylinder. This design was especially popular in some heavy-duty diesel engines and certain European cars because it could generate extremely high fuel pressure before common rail systems became dominant. It offered strong performance, but was mechanically complex and eventually became less common as common rail improved. Electronic fuel injection performance system. In modified performance cars, fuel systems are often upgraded with larger injectors, high-flow fuel pumps, aftermarket rails, and programmable engine management. These systems are designed to support engines making far more power than factory specifications. They are common in racing, drag cars, and tuned street builds, where stock fuel systems cannot keep up. The reason they matter is simple. Once an engine gets more air through turbochargers, superchargers, or higher revs, the fuel system becomes one of the first limits,